So do you hear the term CQRS frequently and wondering what it is? Do you build applications and want to learn how CQRS can help? Or maybe you are a developer who wants to learn about software architecture, specifically application and solution architecture, and want to learn this term, which is very specific in those areas of work. If so, you have come to the right place. This video will explain what CQRS is, so stay with me. Before we get into the CQRS topic, I want to take a few seconds for appreciation. First appreciation goes to the subscriber number 20. Thank you for subscribing. And the second appreciation goes to the readers of my book. I received a lot of positive feedbacks that the book is very helpful for building the careers, for advancing your knowledge, and for building great applications. And so I'm very glad, because that was the exact goal for the book. So thank you. And now let's get to the CQRS topic. What it is, what does it mean? Let's start with the abbreviation itself, CQRS, and it stands for Command and Query Responsibility Segregation. It's very simple. It is about segregating or splitting the responsibilities of the command versus a query. Let's clarify what is a command and what is a query. Command is any kind of operations that has a side effect. For instance, to modify a customer data, that would be a command. And the query is something that retrieves the data and does not have the side effects. For instance, to get the customer information by ID, that operation would qualify as a query. And so while the idea is very simple, you want to split the commands from the queries, the reasons behind it are not as straightforward, and sometimes it helps to clarify those reasons, and that's what we will do next. So everything started from an older abbreviation, which is CQS, or Command and Query Separation. And basically this is a pattern which you apply to your code and class design. Specifically, when you create methods within a class, you want to have separate methods, some of them responsible for the commands and others responsible for the queries, and you don't want to mix them. And the reason behind that separation is to maintain clarity of the code and readability, so that when you look at the method, you understand whether it will have a side effect or not, or whether it will return the data or not. So for example, if you are looking at a update customer method within a class, you expect that the method will have a side effect. And if you're looking at the get customer by ID method within that same class, you don't expect that method to have a side effect. As soon as there is a side effect, it is hard to explain why it is there, and it is hard to remember which method does what. So it requires more learning, more digging into the code. So the code is not so easy to maintain the long term, because anybody who consumes the code needs to go into the code implementation and understand what it really does. So when you separate those responsibilities, it kind of becomes a shared vocabulary. You tell anybody that you're going to write a command, they know for sure that this method is not retrieving the data for you, but it is updating the data. And the other method, which is query, doesn't have any side effects. It just basically simplifies the consumption as well as designing of the code construct, specifically methods within a class. And then we arrive to the CQRS pattern. It actually does not apply specifically to the code and method and class design, although it may as well be drilling down to that areas of work, but specifically it was designed for the higher level concerns, such as on the application or the solution architecture levels. And the term was coined because there was a necessity to optimize the reads or the writes. So one of these operations typically requires optimization, while the other one might not. For instance, it's very common when you design a system and you receive a lot of data modification requests, but the reads are not so frequent. So you want to handle all those data modification needs without impacting the read performance, and the other way around as well. A very typical example would be an airline's ticketing system, when you want to book things and a lot of people are trying to book the same place. So they want to take all your requests and see whichever succeeds first, process that, while the others who are looking at the booking availability are not impacted. And there are some other examples where you want to optimize the queries, and you don't want to optimize the reads. So in other words, CQRS exists because there is some disconnect between the optimization needs of the queries and the commands. And because of these two options, CQRS has two primary flavors when you are optimizing reads and when you are optimizing writes. You typically don't need to optimize both of them together, but sometimes you do, and then you combine the patterns for optimizing reads and writes. So how do you optimize each of them? For read optimization, you typically employ such pattern, which is also considered part of CQRS, as read models. In other words, you introduce an additional object, which is a read model. It is not your domain entities, and you extract or generate your read model contents from your entities or the domain model objects. And so the two are separate. You keep the entities or the domain model objects and you keep the read models. And some kind of refresher or some kind of aggregator job is refreshing the read model by looking at the domain entities and taking the latest data from them and updating the read models. And the people on the websites, for instance, right, they are retrieving the read models only, and they are not looking at the transactional data directly. So that creates some kind of decoupling between the two models, and it increases the performance of the reading because nobody is really reading the transactional data, which gets updated so frequently. And how do you optimize the writes or commands now? You take those commands from users, for instance, the request to book an airline flight, and you put them in some kind of a queue, and then some kind of delayed processor grabs those messages from the queue and processes one by one. So this does not impact anybody who is reading the data, so you might allow them to read the transactional data, and that same data, that same transactional data, which in this case will be the same as the domain objects or the entities, that gets updated by the delayed processor, and the delayed processor can update the data when it does not impact the performance so much. So you have delayed processing of the requests. And so now you should understand what CQRS is, but there are a couple of related patterns which I want to clarify now, because sometimes people think that they are part of CQRS, but they don't have to be. The first pattern is a query object, which means you can represent a query or a request as an object, and then pass that object into the method that is going to retrieve the data or the query implementation, but that object doesn't have to exist. You can just pass in arguments to the query method and it can retrieve the data as a result of that. The second common pattern is also a command object. Basically, you can represent a command as an object, and then you can pass that object into the command method implementation, but again, that is not necessary. You can just pass in some parameters by which the command method can filter the data or know what kind of data it's looking for, and then retrieve that data in response to that kind of invocation. The next pattern is the event or the event-driven architecture. Sometimes people say, this construct might be related to CQRS or might not. I earlier said that when you introduce the read models, you need to keep them fresh in a delayed fashion when the transactional data gets updated. And you might achieve that by using domain events, for instance. And that's where the events come into picture. You update the transactional entities, they dispatch those domain events, and then you react to those events and update the read model. So you might introduce events. The alternate would be not to have events at all, so you keep updating the transactional objects, and then some kind of refresher just runs on a timely fashion and refreshes the read models. Of course, events are more fashionable, but sometimes you don't have constructs to implement them. Specifically for events, something needs to dispatch them, so you need to have an ability to implement the publish and subscribe mechanisms. Sometimes you don't want to do that, sometimes it's just additional hosting need, and you can go without them as well. And the EDA or the event-driven architecture is related to events, and that is how it comes into the picture for this conversation. But I would not relate that too much to the CQRS, because EDA is also a high-level pattern, and it relates to the solution architecture when you connect different kinds of systems and subsystems using events, and not necessarily the events that connect the transactional data with the read model. So those two are two different things, so I would not mix the two. And finally, a special mention to the mediator pattern. I don't think that mediator pattern is necessary to implement CQRS at all. It may even make an implementation awkward, because sometimes you don't want to represent every query and the command as an object first. And second reason is that queries are real time. So when you pass a query object and you're decoupling the query processing from the query dispatching, what's the reason behind that? You really need that response real time, because perhaps the user is looking at the screen and waiting for the query to come back and then display on the screen. And so when you decouple the query dispatching from query processing, you're just adding some distribution overhead unnecessarily. So think about it again before you do it. Alright, that was it. And let's quickly summarize. CQRS is command and query responsibility segregation, and it is about optimizing either reads or queries from the writes or the commands. Thank you for watching, and if you enjoyed, you know what to do. Let me know what you think by leaving comments or suggestions in the below section, and I'll see you next time. Thanks, bye bye.